Hello everyone, in this video I'm walking you through one of my favorite projects, an automated Azure cloud cost forecasting and anomaly detection system, which I built using Meta's profit model. This is a production ready Python system that handles 18 plus cost centers and prevents budget overruns before they happen. Let's dive in. The project is called Azure Cost Forecasting and Outlier Detection System. The core idea is to intelligent machine learning, specifically Facebook profit, to predict cloud cost and automatically flag unusual spending. I am Sajal Agarwal and you will find all of my code on the GitHub, so stay tuned. Let me start with a problem statement, what we are trying to solve. Finance teams manages Azure cloud spending across hundreds of cost centers which they face mainly three critical pain points. Firstly, unexpected spikes, misconfigured resources, which can cost more than $50,000 or or maybe more than that, and which may surprise charges every single month. Secondly, manual monitoring. Teams spend over 20 plus hours per week just reviewing cost reports by hand, mainly through Excel or some dashboard tool. That's half a work week gone. Thirdly, reactive response. By the team, someone notices an issue, it's often days later and the budget has already been blown. So the solution which I built automates the entire pipeline. It predicts costs, detects anomalies within 24 hours, and prevents overruns before they hit. The system is split into two connected projects. Project 1 is the forecasting engine. It uses Facebook profile to predict daily Azure charges for the each cost center, handling more than 800 plus cost centers with 99% confidence intervals on a rolling 24 months window. Project 2 is the outlier detection layer. It compares actual spending against the forecast values, assigns a severity score between 0 and 1, and flags anything that exceeds the 99% confidence upper bound. Those flagged anomalies are then stored for alerting and reporting. So together, these two reports form a fully automated end-to-end cost intelligence system. Let me walk you through the data pipeline. Raw cost data is pulled from Azure Data Blob, merged with historical data from a Postgres database, and then fed into profit model. The output forecast flow back into the database. A few key implementation details are that the data ingestion uses a 12-month rolling window and handles 800 plus cost centers. For profit configuration, I set the interval width to 0.99, used additive seasonality, and applied conservative change point settings. And for efficiency, I used a group by apply pattern to process all cost centers in parallel. The full run completes in just 5 to 10 minutes. Let's see profit model configuration. Uh, this slide is the really heart of the project because this is the model tuning decisions we are bringing into it. Let me break down each parameter and the business reasoning behind it. The interval width of 0.99 means we only flag truly exceptional spending. This directly reduces the false alarms for the finance teams. Additive seasonality mode is used because cloud cost variations are consistent dollar amounts, not percentages. So additive makes more sense than multiplicative here. The change point range of zero point 0.8 allows the model to pick up on recent trend shifts, things like cloud migrations or new projects spinning up. And the prior scale of zero point 0.1 keeps the model conservative. Cloud cost shouldn't change drastically overnight, so we don't want the model to overcorrect. I also added a custom monthly seasonality with a period of 30.5 days to capture billing cycle patterns, specifically those month to end spikes. The result is 60% reduction in false positive compared to static threshold methods. Every real project has technical challenges, and I want to be transparent about the ones I solved here. First, handling 800 plus cost center individually would be slow and messy. I solved this with an elegant group by apply pattern that process all the cost centers in parallel. Second, reprocessing years of historical data every day is computationally expensive. I solve this with a hybrid approach, pulling historical forecast from the database and the only processing new data from the blob storage. Third, month-end billing spikes were constantly being flagged as anomalies. The fix was adding custom monthly seasonality so the model learns and expects those. And fourth, concurrent database writes could overwrite each other. I solved this with an atomic delete, then insert pattern with database filtering. Simple but effective. Now, for project 2, the anomaly detection layer, the logic is clean and interpretable. If the actual cost exceeds the upper confidence bound from the profit, it's flagged as an anomaly. The severity score is calculated as far as how far the actual cost is about that upper bound as a percentage of actual spend. I also track day over day change for trend awareness. Why profit based detection instead of traditional models like Z score or IQR? This is a question which I normally get from my peers. Answer is because profit is context aware. It understands billing cycles. The confidence intervals adapt to variance. There are no manual thresholds to maintain, and severity scores lets the finance team prioritize critical issues over minor ones. This is a much more business aligned approach. Now let me show you a real sample output to make this concrete. Look at cost center 3364 on July 22nd. Actual spend was 2400 against the maximum expected of 1110. That's 54% over budget, which is flagged as a severe hilarity. Meanwhile, cost center 5821 on July 25th spent $7,200 against a max expected of $6,200, 14% over, flagged as moderate. And on all the normal days, like 20th July, 21st, 23rd, spending stayed within forecast bounds, so no false alarms were triggered. This is exactly the kind of output you would surface to a finance dashboard or a alerting system. Here's the full tech stack. For core ML and data processing, I use Profit for time series forecasting, Pandas for data manipulation, NumPy for numerical operations, and all in Python 3.8 plus. On the cloud infrastructure side, Azure Blob storage for raw data, Azure PostgreSQL for storing forecasts, and SQLAlchemy as the ORM with SSL enabled connections. For deployment, the system is built to run as a scheduled script in Azure function and cron compatible and is Docker containerization ready. The code base follows clean engineering practices, model structure, environment variable management, and production ready error handling. Now let me close with the numbers that matter. The system monitors over 800 cost centers covering $15 million in monthly Azure spend. It achieves a 99% confidence interval on forecast, and it reduced false positive by 60% compared to static threshold approaches. More tangibly, it detects cost anomalies within 24 hours, enabling rapid response. It prevented more than 50,000 in unexpected charges by catching misconfigured resources early, and it reduced manual cost review time by 70%, freeing up the finance team for actual strategic work. This is a production ready system with full error handling, logging, and database transaction safety. And that's the full walkthrough of the Azure cost forecasting and outlier detection system. If you want to dig into the code, and you can find full repository on my GitHub. It's called time series forecasting via meta profit model. If you found this useful, please like and subscribe. And if you have question, whether it's about the profit configuration, the database design, or how to adapt this for your own cloud environment, drop them in the comments. Thanks for watching.